Okay, this will introduce the concept of velocity. So I'm going to be using an applet called Moving Man, PHET, out of the University of Colorado. And so what this applet allows me to do is to choose an initial position for the man, which I'm putting him at -10, um, and give him a velocity of 2 meters per second. So this could be plus or minus. It's plus 2 meters per second, so that means he's going to be moving in the positive direction. Um, at a velocity of 2 meters per second. And so let's let him go here to the end of the meters of the distance scale here. So there he is at the end, and now what I want to do is I want to do a playback if I can, and I'm going to set this slow so we can do what's called a motion diagram. Okay, so for the motion diagram, let's see, I'm going to need to, yeah, this is good. So what I want to communicate is that at time 0, he is at position -10, and 1 second later. So let's start him walking again. This is a playback of what we just did. Oops, I'm having trouble here. Okay. So in 1 second he's gone. It's giving me some decimals here, but essentially he's gone 2 meters to the right. So that puts him at -8. And so if you look at my scale here, every 2 little divisions is 1 meter. And so he's gone from -10 to -9 to -8. He's gone in time delta t of 1 second. He's made a displacement from there to there. Okay. If I let him go another second, he's going to be at -6. Okay. So he's gone 2 meters to the right. Now he's going to go another 2 meters to the right, which will put him right here. So he's at -6. So I'm going to put a dot right there, and I'm going to draw another displacement vector. And so he's going to continue at constant velocity, and every second he goes another 2 meters to the right, and then another 2 meters to the right, and then another 2 meters to the right. So now he's at 0, and he's going to go another 2 meters to the right, like this, and like this. And then finally he's going to reach +10. And he does that in 10 seconds. Because each one of these is a delta t of 1. So how many displacement vectors have I drawn? Well, if you count them all, you'll see that there are 10 separate delta t's in 1 second. So it's taken him 10 seconds to go from the left side to the right side. So what I can also do is I can, let's clear this, and we're going to now set him at 10. Okay, so he's at 10, and he's at 10. I want to set him on the right side here, and I want to give him a velocity of -2 meters per second. And I want to Now have him execute that motion. So now he's moving at minus 2 meters per second. He's moving in the negative direction. I'm going to stop him when he gets to the other side there. And so what that would look like is, I'll draw the motion diagram down here. So in this case, he's going to start on the right side, and he's going to now be making displacements in the negative direction. So he's going to go 1 meter, 2 meters, going to displace himself that way, 2 meters. Then he's going to go 1 meter, 2 meters every second. Delta t again is 1 second. 1 meter, 2 meters. And so we'll get a motion diagram that looks very much like the one that we did on the top, except that now the displacements are going in the opposite direction, and that corresponds to a velocity of minus 2 meters per second. So if you look at these two motion diagrams here, let me just finish this one up here. His speed in both of these situations is the same. Speed is the absolute value of the velocity. But in the upper case, he's going at plus 2 meters per second. And in the bottom, he's going at minus 2 meters per second. So the definition of velocity is, let me just write this maybe down on the bottom here. Velocity, and technically speaking, this is average velocity, is the displacement divided by the corresponding change in time. And so that would, in typical units that we would use, that would be meters per second. And so in the top case, where the displacement is in a positive direction, the velocity is in a positive direction. And in the bottom case, where the displacements are in a negative direction, the velocity is in a negative direction. So one really important thing to remember here is that velocity and displacement are always in the same direction.